In the last video, we talked about ways lines can be related. They can be parallel, meaning they never intersect, but they're on the same plane. They can be skew, meaning they never intersect and they're on different planes. And they can be perpendicular, meaning they intersect at 90 degrees. There's a fourth possibility, which is that they just don't cross at anything interesting. They just intersect. Now, from what we've talked about so far, we also know that lines, when they intersect, have interesting things happen. So for example, there are two lines that intersect. We've talked about the idea that we have vertical angles. That's these ones in red and these in blue. Those would be vertical angles because they're kitty-corner from each other, and we have a property that tells us that however big one is, the other is as well. Vertical angles are equal to each other. We also know from other properties that if two angles together form a straight line, that there's another term for that. Those are called a linear pair. This should be reviewed from our last section. So we have the linear pair. So vertical angles and linear pairs. Now, maybe lines might intersect at right angles and be perpendicular. So for example, I can have line L and line M, and I can say line L is perpendicular to line M. That can happen. And then other things are going to follow from that. What we want to look at right now, however, is one other new idea, and kind of goes like this. If I were to take two lines, so here's a line, here's a line. I want to cut across them with a transversal. So we're going to call that line there the transversal. Meaning it goes across the two lines. Now, if you think of my two black lines as railroad tracks, and then you've got the wood supports that hold them together, each of those wood supports transverses the two tracks. Each of the ties transverses those two trans as a prefix. Means to go across. The Transcontinental Railroad went across the continent. A transatlantic flight, Charles Lindbergh, went across the Atlantic. A transversal line goes across the other two lines. So, now that we've got that in front of us, we're going to talk about special angle pairs that are created. So for example, this angle right here and this angle right here are both in the same position. We call those, I'm going to use some color here to help now, corresponding. Corresponding angles are two angles, so it's a pair that are in the same relative position between the two lines. So I'm going to put some numbers up here to help. So angle 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so corresponding angles will be angles 3 and 7. We're going to be talking about angle pairs here. Another pair of angles that we should be able to identify are going to be same side, let me change that, alternate interior. See, notice the red markings are inside the two lines, and they're on opposite sides of the transversal. So we call those alternate interior angles. And so in this case, those alternate interior angles are going to be things like angle 3 and angle 6. It would also be angle 5 and angle 4. See how they're also still on the inside? And they're on opposite sides of that transversal. Now that's a little different then say angle 4. There's 4 and 6. Now those angles we call same side interior angles. So if they're on the same side of the transversal and on the interior, that's the same side interior angles. That will be that name of the pair. So angle 4 and angle 6, same side interiors. Now there are other pairs of angles there. For example, 3 and 5 are same side interior. Let's go back to corresponding for a moment. Now notice that the corresponding angles are on the same side of the transversal, but one's in the interior, one's in the exterior. We've got interior and exterior for those. Corresponding do that. They're always on the same side of the transversal, so either over here or over here. And then I usually call it the same position. Like I would call this position the southwest position. So southwest, southwest. I could also pair up angle 8 and angle 4. They're both in the southeast positions. They're both on the same side of the red transversal, but they're on opposite. One's interior, one's exterior. The last kind of angle pair you need to know are going to be, let's see if I have one more, another color. I'm going to have to use black for this one. And that's going to be something like angle 2 and angle 7. We call those alternate exterior angles. Again, they're on opposite sides of the transversal, and they're both in the exterior. Angle 2, angle 7 will be those guys. So we've got these pairs of angles we're working with. So wherever I take two lines and draw a third line through them, I create these pairs of angles. Let me do one more demonstration of this idea though. Let's take some lines. So here's a line, here's a line, and here's a line. Let's slap some labels on them. And I'm going to actually move these so that the camera doesn't cut them off. There we go. So now you can see the lines and me. Let's label them. I'm going to call this line L, line M, line N. So notice that L right here, and let's see, so L goes here, M goes here. N is a transversal to them because it cuts across both of them. Now, likewise, let's see if I can change that up. See, N is the transversal. L and M go up there, N cuts across them. And that's going to create some angle pairs. So for example, this angle here corresponds to this angle over here. Follow that? Now, I can also, let's put that back into being a solid line. Let's go ahead and talk about what about M, N, and M making L the transversal. Sticking with that same color highlighter I used, this angle will then correspond to this angle. They're on the same side of the transversal, and one's in the interior, one's in the exterior. They're both, in this case, in the northeast position. And that's one of the things about this. You're not always going to see nice, neat lines running side by side with a transversal slapped across them. You have to be a little creative about how you look at these. Always look for 3 lines, 2 lines, and the third intersects both. And that's how you know you're looking at a transversal. All the angle pairs come from that.